Alright, in this video we're going to go over the solutions to the final exam for the 11 o'clock section. I put these files in this spot in class code, so I made a directory exam3a. Let's see. Put the on paper portion first. Okay, run the algorithm. This is the same as the last exam. Start with these numbers. What does selection sort do? It goes and looks for the smallest number, that's -2, and puts it in front. It puts it in front by swapping with the one that's in front. So it would be a -2 there, and that gets switched with the -1. Alright, that's different than putting the -2 in the front, because everything after it would have to be shifted down. The reason you just do a swap is because if you're just swapping two values, that's fast. If you're putting the -2 in front and shifting everything down in the array, you'd have to do, that would take longer. Alright, so here we already have the smallest there. So the next step, we're going to look for the next smallest, which is -1. Swap that with the 2. I'm only touching 2 spots in the array each time. Next smallest is the 0, so the 0 and the 4 get switched. Next smallest is the 1 and the 4 get switched. And after this point, it would check for the next smallest, which is 2, it's already in the right spot, and then 3 and then 4. If we look in, there's a grading file here that summarizes what points were taken off. And for most of you don't have your exams anyway, but you can look at that file for what people did. Alright, the second one, encrypt farewell all using Caesar cipher and password 5. First thing to do is to write out the alphabet. Okay, and then farewell all. For the F, we're just going to count over 5. 1, 2, 3, 4, 5. That's K. A is 1, 2, 3, 4, 5. F. From R, W. From E, J. W. 1, 2, 3. Then we have to wrap around 4, 5. E we already figured out was J. L is 1, 2, 3, 4, 5. Space leave alone. The A we already figured out is F. Okay, unless I made any mistakes in counting, that would be it. Password is just saying which way to shift. Convert hexadecimal number D2 to decimal. The easiest way to do this is to remember that D2 hexadecimal means that you're doing this 2 is the ones digit and the D is the second digit. And regular numbers, that would be the tens digit, but in hexadecimal we're base 16, so this would be 16 16's digit times D plus 1 times 2. Alright, so the 2 is the ones digit, the D is the 16's digit, and then you need to remember what D is. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the regular digits, and then you have A, B, C, D, E, F. And the A is 10, the B is 11, the C is 12, 13, 14, 15. Okay, so the D is 13 then. So this would be 16 times 13 plus 2, whatever that works out to be. 210. The other way to do it is to look at what D2 is in binary. D is 13, so that would be 1101, and 2 is 0010. 1101, that's 8 plus 4 plus 1, that's 13. Okay, so then this would be the 1's bit, 2's bit, 4, 8, 16, 32, 64, 128. So that would be 128 plus 64 plus skip 32, 16 plus 2. That also ends up being 210. Whichever way you do it is fine. Determine if the number 79 is prime. So first you need to know the square root of 79 is 8 point something. That means we need to test all the numbers: 79 over 2, 79 over 3, 79 over 4, 79 over 5, 79 over 6, 79 over 7, 79 over 8. 79 over 9 is bigger than the square root, so we don't have to test that. Okay, 79 over 2 is 39, remainder 1. Okay, there's a remainder, that means 2 is not a factor. 79 divided by 3, 26, remainder, of course you could do this in your head or on paper. 79 over 4, we're going to have 19, remainder 3. 79 over 5 is going to be 15, remainder 4, unless I'm making mistakes. 79 over 6 is going to be 13, remainder 1. 79 over 7 is 11, remainder 2. 79 over 8 is 9, remainder 7. Okay, so none of those evenly divides, therefore 79 is prime. Alright, on to the computer. The one with loops here, we start off, our variables are 2 and 1, and total is 0. First thing, check on the while loop, is x equal to 0? No. So we do the loop. First thing in the loop, change I to be 2. Next, total is x plus total. X plus total is 2. Then we check x mod 2. X mod 2 is 0. Remainder is 0. Okay, so then we do this part. We don't do the else. X is x over 2. 2 over 2 is 1. And then, is I bigger than 10? No. Then we go back up and check, is x equal to 0? No. Then we're going to do the loop again. I plus plus, I goes to 3. Total equals total plus x. Total plus x is 3, that's the new value for total. Now we check, is x mod 2 equal to 0? X is 1 now. 1 mod 2 is 1, remainder is 1. Then we're going to do the else this time. So we have a 1 in here for x. 1 minus 1 is 0. 0 times 2 is 0. Now x is 0. Next is this line here. Is I at least 10? No. Then we go up, check the while condition. Is x 0? X is 0, that's the stopping condition. As long as x is not equal to 0, we keep going. Now x is 0, that's the end. This would be your final answer. Next one is our functions. Alright, we start off at the beginning of main, always. We have initial values there. X is 1, y is 2, z is 3. Okay, next line we go to is this F1. And we're going to copy in the values y and z. Right now that's 2 and 3 into F1, x and y. So x gets the value of y, which is 2. And y in F1 is a different variable, and it gets the value of whatever's here, which is Z3. Okay, so that's in F1. Those values are copied in, and those are different X and Y than the X and Y in main. First thing we do, set temp equal to X. That's the X in F1. Temp equal to 2. Next line, X equals Y, Y equals temp. That's the variables in F1. X equals Y, so this 3 goes into X, and Y was equal to temp. That's a 2. So it switched the values of X and Y here. And then we're going to run F2, and we're going to copy in the values X and Y into F2. So this X, value of X goes into this Z, and the value of this Y goes into W. X and Y get copied into Z and W. Let's go down to 2, so this gets X, 3, and this gets Y, 2. And then we run the F2. Temp is equal to W. Temp is equal to W, that's the W in here, which is 2. And then these are the lines already, W equals Z. Now W is 3, Z equals temp. So Z is 2. Then F2 returns W. That's this right here. I'll just sort of make a note here. That 3 is returned. And where does it return? Wherever F2 was called, which was up here. So that's that value 3. The value of this right here then is 3. That gets sent back to main. And that was copied into X. That means back in main, X turns to 3. And all these other variables actually disappear at that point. They're not there anymore because those functions are done. We'd have the variables X is 3, Y is 2, Z is 3. And then we're going to call F2 with X and Z. It's this X and Z from main that get copied in to Z and W. X and Z are both 3. Those get copied into Z and W. So this Z is going to be 3. Maybe I'll put a semicolon to say that we're running the function in new time. And there's a 3 there. Temp is equal to W, so that's a 3. And then W is equal to Z, that's 3. The values don't change, they're all 3s. And then the W is returned. Then this value F2 of X and Z is that W, which is 3. That means this Y is going to become 3. Alright, so the main thing to keep track of here is every time you have a new function, it uses its own variables. Even if they're the same name, it keeps its own variable. And if you're inside of some function and you say X, it's going to look inside of that function for its own variables, and it's not going to mess around with the other function's variables. They're separate. Alright, on to the arrays. Start off at the beginning. Message is hello. And there's room for 10 characters. I only have 5 there. I'll just write the ones that are there. And the value of I isn't specified. It'll go 0 first off. So the for loop start at 0, go up by 1 each time, keep going as long as you're less than 5. So it's going to go 0, 1, 2, 3, 4, 5. And the last time it actually does this statement is when I is less than 5, which is this 4. Alright, what happens at the first time? We have message bracket 0. That's where the H is message bracket 0 plus 1. That's H plus 1. So I'm just going to put here H plus 1 is what? I. And the other ones are not changed. That's when I is 0. When I is then 1, we have message bracket 1. That's where the E is. So E the spot where the E is going to become E plus 1. And what's E plus 1? F. And we keep going like that. L becomes M. O becomes P. And that's when I is 4 because we have position 0, 1, 2, 3, 4. When I becomes 5, we do this check. And 5 is not less than 5, so it's done. And then we're going to move on to the next loop. So I will start over again. I'll put a semicolon. Here it starts at 0 and it only goes up to 1 less. So instead of up to 5, it's going to go up to 4, and the last time it does the loop, this part in here, is when I is 3. And I'm going to put over here what the string looks like. So just that's what it starts as. And in the first loop, we have message bracket 0 is message bracket 1. When I is 0, this is 0, this is 1. So instead of the I, we're going to put in the thing that's at the next spot. So it would be an F there, and the rest of the string didn't change yet. Okay. Next time, I is 1, so this is message bracket 1 equals message bracket 2. So that means the M is going to get copied in to where that F was. And the rest of the string doesn't change. Next time, I is 2, message bracket 2 equals message bracket 3. Then this M gets copied in here, and the rest of the string doesn't change. Next time, I is 3, message bracket 3 equals message bracket 4. This P gets copied in, and the rest of the string doesn't change. When I becomes 4, that would be corresponding to this position here. The loop doesn't happen, and this would be the final value of the message. Alright, that's the end.